Question 13.5 is on probabilities of independent and dependent events. A compound event consists of two or more simple events, and two events are independent if the probability of one event occurring does not affect the probability of the other event occurring. And the two events are dependent if the probability of one event occurring changes the probability of the other event occurring. So let's take a look at a couple examples here. Determine whether the events are independent or dependent. Number one die is rolled, and then another die is rolled. These two events are independent of each other because rolling the second die, or the outcome of the second die, is in no way dependent on the rolling of the first die. So those are independent. Example number two, a card is chosen from a deck of cards and is not put back. Then a second card is drawn from the deck. The second event here is dependent on the first event, because once you draw a card from a deck of cards and you don't put it back, you've changed the total number of cards left in the deck. So drawing the second card depends on what happened with drawing the first card. So the probability of independent events is defined as the probability that the two independent events occur. It's the product of the probabilities of each individual event. So the probability of A and B happening, where B does not depend on A, is the probability of A times the probability of B. Let's take a look at an example of that. A coin is tossed and a die is rolled. Now these are independent events because rolling the die is in no way affected by the coin being tossed. Tossing the coin does not change the outcome of the die being rolled. So let's find the probability of tossing heads and rolling a 6. So the probability of heads and a 6 is equal to the probability of heads times the probability of a 6. The probability of tossing a coin and getting heads is 1/2, because there are two sides, heads and tails, and heads is one of those. And the probability of rolling a 6 is 1 out of 6, because there's only one 6 on a 6-sided die. So the probability of both of those two events occurring is 1/2 times 1/6, or 1/12. Here's another example. A card is drawn from a deck and replaced. Then a second card is drawn. What is the probability of drawing a heart and then a king? Because that first card, once it's drawn, is replaced, drawing the second card is not at all influenced by whatever you drew the first time around. So we're looking here for the probability of a heart and then a king, and this would be with replacement. So that's going to be the probability of a heart times the probability of a king. In a standard deck of cards, there are 13 hearts out of a total of 52 cards, and there are 4 kings out of a total of 52 cards. And plugging that into my calculator, I get that probability is 1 out of 52. The probability of dependent events. The probability that two dependent events occur is the product of the probability of the first event occurring and the probability of the second event occurring after the first. So in other words, if the second event is dependent on the first event, I have to take into account kind of what has changed, what has created a different situation there. Let's take a look at an example and maybe it'll be a little more clear. 3 cards are drawn from a deck without replacement. That's what makes this a dependent situation, because when I do not put that card back, it changes the total number of cards in the deck. So what is the probability that all 3 cards are diamonds? So the probability of a diamond, followed by another diamond, followed by another diamond. Okay. So the probability of the first card being a diamond is 13 out of 52. because there are 13 diamonds in the deck and a total of 52 cards. Now, if I did not put that first card back, now there are going to be 51 cards in the deck, but I could have already pulled out a diamond, so there would be 12 diamonds left in the deck. And then for the third card, I've already taken 2 out, so there's a total of 50 cards left in the deck and 11 diamonds. And plug this into your calculator, and it's very straightforward. Just do 13 divided by 52 times 12 divided by 51 times 11 divided by 50. Math, enter, enter, and you should get 11 over 850. No need to use parentheses when you're doing all multiplication and division. So in this section, we talked about the probability of independent and dependent events. 2 events are independent if the probability of the second one happening is not in any way dependent on what happened the first time around. So this is often going to be something like rolling a die and drawing a card, completely separate from each other. 2 events are dependent if the probability of the second event happening is in some way influenced by the first event happening. And this is going to be most of the time drawing a card out of a deck and not replacing it.